So this is the Osmania University syllabus, Hyderabad. So this is not only for Osmania University. This is common core syllabus for all universities, of Telangana. Okay, not for Andhra Pradesh. This is common core syllabus for all universities of Telangana. Okay, for the students who admitted from the era of 2019 to 2020 batch onwards. Okay, those who joined from 2019 to 20, they will have to study these syllabus. Okay, so in the first semester, you will study about differential and integral calculus. Okay, so this will be teach for 6 hours per week, and marks, the maximum marks is for 100 marks, and the credits are given five. Five credits are given for this differential and integral calculus. Now coming to the second semester syllabus, that is differential equations. Okay, first one is differential calculus, and now this is differential equations. Okay, so this is also for 100 marks, and five credits are given for this subject. Okay, this is about first year syllabus. Now coming to this is first year syllabus. Now coming to the second year syllabus. In second year first semester, that means what, third semester, we will study about real analysis. Okay, so the third semester syllabus is real analysis, and the fourth semester syllabus is algebra. So algebra is studied in fourth semester. Okay, so this is about second year syllabus. That is real analysis and algebra. In fifth semester, coming to the third year syllabus. Okay, so that is what, in fifth semester we study about linear algebra. So this is advanced topic to algebra. So continuation we will study uh, after that for fourth semester. That means in fourth semester we will study algebra. Immediately after that we will study linear algebra in fifth semester. Okay, so in fourth and fifth semester we study about algebra and linear algebra. Now coming to the sixth semester. So you have options like numerical analysis and integral transforms and analytical solid geometry. Okay, so these subjects for sixth semester. So let us see the complete syllabus of each and every paper. Okay, so we'll discuss about the complete syllabus of first semester, second semester till sixth semester. Now coming to the first semester. Okay, so in the unit, so this course is aimed to exposing the students some basic notations of differential calculus. Okay, outcome is what, by the time students complete the course, they realize wide-ranging applications of the subject. Okay, so this is from the academic year 2019 and 20, and I already said this is 5 credits for 5 credits. So coming to the first unit. Okay, first unit is what, differential and integral calculus. Differential. So first of unit is partial differentiation. Okay, so partial differentiation. In partial differentiation, first we study about the introduction, and after that function of two variables. Okay, and neighborhood of a point of AB, and then continuity of a function. So all these are based on function. First of all, function of two variables, neighborhood of a point AB, and then continuity of a function of two variables, and continuity at a point. Okay, continuity at a particular point. Okay, then limit of a function of two variables, and after the completing different concepts on function, we study about partial derivatives. Okay, partial derivatives and geometrical representation of a function of two variables, and then homogeneous function. Now coming, this is about first unit, that is on partial differentiation. Now coming to the second unit. So first unit on partial derivative differentiation. Now this is on total differentiations. Okay, so in the first one, theorem on total differentiation. Second one is composite function, and after that, differentiation of composite function, implicit function, and equality of f of xy of a comma b and f of fyz a comma b. Okay, and after that, Taylor's theorem of a function of two variables, and maximum minimum of a function of two variables, Lagrange's method of undetermined multipliers. Okay, now coming to the third unit. So third unit is called so introduction, definition to curvature, radius of curvature, length of arc. So like this, we have many topics, and unit 4 also we have, you can see in unit 4 also, length of plane curves, volumes, and surfaces of revolution. Okay, like this you have 4 units and textbooks you can follow Shanti Narayan differential calculus, that is Chand, and Shanti Narayan integral calculus. Shanti Narayan for differential calculus and Shanti Narayan for integral calculus. Okay, I think these are enough. There are many other books also there. Harikishan differential calculus. Okay, many are there, but I think these two are enough. Okay, now coming to the second semester syllabus, semester 2 in first year, that is differential equation. Here also we have 4 units. So unit 1, unit 2, unit 3, and unit 4. Okay, so the objective is, the main aim of this course is to introduce the students of techniques that solving differential equations. So techniques to solve differential equations and to train apply their skills to solve some of the problems of engineering and sciences. Well, this is the objective of this paper. So after learning this course, you can solve the various differential equations. So this is the outcome of the course. And in unit 1, we study differential equation of what first order and first degree. Okay, and so in this we have introduction to the differential equation, equation which in the type of variable separable and homogeneous differential equations, and then differential equation reducible to homogeneous. So first one is homogeneous differential equation, and second one is differential equations reducible to homogeneous form. So that means that those equations are not in homogeneous form. So then we'll reduce that equation into homogeneous form. Now coming to the another differential equation, that is first one is variable separable, second one is homogeneous, third one is linear differential equation. So in that we will again we have the differential type of differential equations that we have to reduce into linear form. Okay. After that, the fourth one is exact differential equation. So in this, we'll study about integrating factor, then change into variables, after that total differential equations, and after that simultaneous total differential equations, and the equation of the form dx by p equals to dx by dy by q equals to dz by r. So this is about unit 1 in second semester. That means in second semester differential equations. Okay. So this is about differential equation of first order and first degree. Coming to the unit 2, this is also first order, but coming to the degree, that is not, which is equal to 1. That means what? Differential equation of first order but not first degree. Here differential equation of first order and first degree. Okay, that is the difference between unit 1 and 2. So here also various methods are there. First one is equations solvable for p, and then equation solvable for y, and then equation solvable for x. Okay, then after that equation that not equation that don't contain x, y. Okay, after that equations homogeneous in x and y, equation of the first degree in x and y, Claira's equation. Okay, after that next topic is applications of first order differential equation. So what are the applications of first order differential equation? So growth and decay, dynamics of tumor growth, radioactivity, and carbon dating compound interest and orthogonal trajectories. Okay, these are the applications of what first order differential equation. Now coming to the higher order. So first order is over. Now coming to the higher order linear differential equation. So this is this is unit 3. So in this you will study about solutions of homogeneous different linear differential equation with constant coefficients. So in first order also we have linear differential equation, but here their order is 1, but their order is higher order than more than equal to 1. Okay, so solution of homogeneous linear differential equation with constant coefficient, solutions of non-homogeneous differential equation, and that is PD of y equals to q of x. So first one is solution of homogeneous with constant coefficient. So the coefficients will be constant. Is a solution of non-homogeneous equation. Okay, so these are homogeneous and these are non-homogeneous differential equation. That is what PD of y equals q of x with constant coefficient by means of polynomial operator when q of x will be changing here. Okay, first one is q of x will sound like this: b into e power x. Second one is b into sine ax, or sometimes b into cos ax. Okay, now another method is another function we have like this in the place of q of x, like this, what b into x power k, and fourth one is v into e power ax. These are comes under what non-homogeneous differential equation. Okay, so method after that method of undeterminate coefficients, and now coming to the unit 4. So what is that? In unit 4 we have first unit is about differential equation of first order first degree, second is first order but not first degree, and third one is higher order, and unit 4 is method of variation of parameters and linear differential equation with non-constant coefficient. They are non-constant coefficients. And the Cauchy-Inverse equations, legendary linear equations, and like that partial differential equations also we have formation of solution equation, easily integrable linear equation of the first order. Now coming to the second year syllabus. So from first in 1.3, that means so third semester syllabus, that is real analysis. Okay. Here also we have 4 units: unit 1, unit 2, unit 3, and unit 4. First one is sequences. So in sequences, we study about limit of sequences, and after that a discussion about proofs on limit theorems for sequences. After that, monotone sequences and Cauchy sequences, and then after that subsequences, limit supremum and limit infimum, and coming to the S series, alternate series, and integral test. So this is about the first unit, that is on simply we can say that sequences and series. Okay. Now, so in second unit, study about continuity. Okay. So continuity we study about continuous functions, properties of continuous functions. So first we study about continuous function. After that, those properties and uniform continuity and limits of function. Okay. So next coming to the unit 3. So after continuity, we will study about differentiation. So basic problems in differentiation. The first concept is basic properties of derivative, and after that we have mean value theorem and L'Hospital rule and Taylor's theorem. Okay. Now continuity over, differentiation over. Now coming to the integration. So integration is on the integration. The first one is Riemann integral, and then after that properties of Riemann integral, and after that fundamental theorem of calculus. Okay. So this is about third semester syllabus. That means first you study in second year this paper. Now coming to the fourth semester 4 year, second year. Okay. Now algebra. So this course, what is the objective of this course? This course is aimed to exposing the students to learn some basic algebraic structures. Okay, like groups. Okay. So what is the outcome on successful completion of the course? Student will be able to recognize algebraic structures. Okay, arise in matrix algebra, linear algebra, and will be able to apply the skills learned in understanding various such subjects. Okay. So first one is unit 1 is groups. Okay. So first we'll discuss about the definition of group, and we'll study about examples of groups and elementary properties of groups, finite groups, subgroups, and terminology and notation of subgroup notation and subgroup tests and examples of subgroups. So after completing groups and subgroups, we study about cyclic groups. So properties of cyclic groups, classification of subgroups, cyclic groups. Okay. Now coming to the unit number 2. So in this we study about permutation group. So first we'll study about definition and notation and cyclic notation and properties of permutation, a check digit scheme based on D5, then isomorphism, motivation, definition and examples, Cayley theorem, and its properties of isomorphism, automorphism, cosets, Lagrange's theorem, properties of cosets, 138, Lagrange's theorem, and consequences and applications of cosets, permutation group and rotation group of PQ and superbar. Okay. Now unit number 3, normal subgroups, factor groups. Normal in that we'll study about first normal subgroups, factor groups, applications of factor groups homomorphism, definition and examples, properties of homomorphism, and first isomorphism theorem. So we'll still study about normal subgroups, homomorphism, and isomorphism theorem. Now after that, after completing groups, we study about rings. To understand the rings also we need to know about groups. Okay. So in this we study about introduction to rings, motivation and definition, examples of ring, properties of rings, and subrings. After that, in ring, the next concept is integral domain. Definition and examples, fields, characteristics of a ring. Okay, now coming to the unit 4. Okay, ideals and factor rings, ring homomorphism. Ideals of ring and factor rings, study about ideals, factor rings, prime ideals, and maximum ideals. Ring homomorphism, definition of and example, properties of ring homomorphism. So from this, okay, introduction to rings. From these topics about ring, and remaining are unit 1, unit 2, unit 3, and unit 3 also the first of part, that is normal subgroups and factor groups about group theory. So this is group theory, and this is ring theory. So this is about algebra semester 4 syllabus of BSc Mathematics for all universities in Telangana. Now coming to the fifth semester, that is in third year, first semester, 3-1, like we call it as 3-1. Okay, so that is as linear algebra. This is from academic year 2021 and 2022. Okay, so what is the objective of this course? The students are exposed to various concepts like vector space, basis, dimension, eigenvalues, etc. So outcome after completion of the course, students appreciate its interdisciplinary nature. Okay, first one is unit one is vector space. So in vector space, we'll study about vector spaces and subspaces, null space, column space, and after that transformations like linear transformations, linearly independent set, basis, coordinate system, the dimension of a vector space. So this is about unit one. Now coming to the unit two, rank change, rank change of basis, eigenvalues, eigenvectors, the characteristic polynomial, and the characteristic equation. Now coming to the unit three, diagonalization, eigenvectors, and linear transformation, complex eigenvalues, applications to the differential equations. Okay. Now coming to the unit number 4, orthogonality and least square. In that we'll study about inner product space, inner product length and orthogonality, orthogonal sets, orthogonal projection, the Grams with our process. Okay. So this is about fifth semester syllabus. That means first year, final year. In final year we will study about linear algebra. Alright. This will study about the completion of linear algebra, completion of algebra in fourth semester. In 2-2. In 2-2 we'll study about algebra. Immediately after that, in 3-1, continuation to the algebra, that is linear algebra. So to understand linear algebra, that means to understand vector space also, we need to understand about what is ring, what is group. That's why we study in order that algebra, after that linear algebra. Okay. And first one, numeric analysis. This is optional paper with effective from the academic year 2021-22. So in this also you have 4 units. Okay. So in first unit, you will study about errors in numerical calculation, solution to the equation of one variables, the bisection method, iteration method, the method of false position, Newton's method, Muller's method, and solution of the system of non-linear equation. This is about first unit. This is the second unit, interpolation of polynomial and polynomial approximation. So you have here also various methods like Gauss and Stirling, Bessel's, Lagrange's, Newton's, and inverse calculation like this. Okay, after that we have curve fitting. So least square curve fitting, fitting of a straight line, non-linear curve fitting, numerical differentiation and integration. Here also we have differentiation by integration, but here we apply the numerical methods such as like Simpson 1/3 rule, Simpson 3/8 rule. Okay, like that. Okay, so numerical differentiation, numerical integration, trapezoidal rule, Simpson 1/3 rule. Okay, now coming to the unit 4, numerical solution of ordinary differential equation. Okay. So Taylor's method, Picard's method, Euler's method, and Futter methods. Okay. Now coming after that, this is another optional paper, integral transforms. We have 4 units here also. So first one is Laplace transform and inverse transform, application to the ordinary differential equation. After that, Fourier transforms. Okay. Now after that, analytical and solid geometry. Here we have also 4 units. And first one is sphere. After that, cones, cylinders. After that, continuation the right circle cone and cylinder. And fourth one is conchoid. Okay, so this is based completely based like geometry. Okay, so some shapes are there like sphere. Okay, so when passes through the 4 given points like of a circle, intersection of a sphere, line equation, tangent plane, angle of intersection of 2 spheres, radical plane. Okay, so this is about BSc mathematics syllabus for all universities in Telangana like Osmania University, Kapi University, Palma University, Satana University. Okay, so this is about the BSc Math syllabus. Okay, so these are the 6 papers, and each paper is for 100 marks. Okay,